Good morning, students. Today we are going to start our first chapter, that is chapter number 3, Force and Pressure. All of you get ready with your books and pencil in your hand to mark important points. All of you come to the page number 38. Here the topic force is given. Now this concept we have done in class 7th also, where we have learned that force is a push or pull on an object. Whenever you apply a push or a pull on an object, you call that object has exerted a force. So this is what we have learned in class 7, that force is a push or a pull exerted on an object, and this force, whenever exerted, it produces some effects. Now what are those effects? It can change the state of an object. When we say state of an object, either the object come to rest or it starts moving. For example, when you are playing with the ball and you kick the ball was at rest and you kick the ball come into motion. But when a moving ball is thrown towards you and you catch the ball come to rest. So this is how, by exerting the force, we can change the state of an object. You can even change the direction of the moving object while by applying the force. For example, you are playing cricket. In the cricket, with the help of bat, we can change the direction of the moving ball. You can even change the speed of the object. For instance, you are paddling the cycle, and if you start paddling it faster, you applied more force and the cycle will run fast. But when you apply brake, the speed slow downs. Applying brake means applied the force and the speed slow down. And the last effect of the force is change in the shape and size. For example, I have this rubber band with me. On applying the force, I can change the shape and size of this object. So these are the few effects which you have learned in your previous class. And in the present class also, if I ask you to write down an example where the effect of the force is change in speed, you should be able to give me the answer for this. If I ask you to give me an example where effect of the force is change in the direction, so for all these effects, you should be able to give me the example for this. Now next important point is force require both magnitude as well as direction. What we mean by the term magnitude means amount. Whenever we apply force on any object, we have to think about the magnitude. For example, this box is here. Say this box is of 100 kg. At that time, you have to think about how much force has to be applied. Or this box is simply of 2 kg. Then you will think about the force and the amount which has to be applied on it. So force is a quantity which, whenever it has been exerted on the object, we have to think about the amount. How much force to be applied on the object. Next is the direction. If I ask you to push this box towards I want this box to move in this direction. So when I am thinking about the direction of motion, I have to think about the applied force. So for example, this pencil, I asked you to push this pencil upward. Now for pushing the pencil upward, I have to apply the force in this direction. Okay, I can't apply the force in any other direction. There is one direction only. So whenever we apply force on any object, we have to think about the direction of the force. In which direction I should apply the force so that the object can move. Now next important point is SI unit of force. This SI unit is Newton, and we will we have to define this 1 Newton. Now, all of you come to the page number 39, page number. These are the few important points which we have to underline. That SI unit of the force is Newton. And how to define 1 Newton? 1 Newton is defined as the force which, when applied on a moving body of mass 1 kg in the direction of its motion, increases its speed by 1 meter per second in 1 second. What do we mean by this statement? For example, you have a 1 kg of object with you, 1 kg of object, and you are changing its speed by 1 second, for example, by 1 meter per second, for example, 30 to 31. And in how much time? In 1 second that change occur. Then we say 1 Newton of force has been exerted on the object. Now, after defining the Newton, we will find out the relation between 1 kg force equals to how much Newton? It is equal to 10 Newton. Now, what is 1 kg force? Look at this figure. This is an object which is 1 kg force, and earth is exerting force of attraction on it. So, this earth will produce 1 kg force of attraction on this body of mass 1 kg, and this 1 kg force exerted by the earth will be approximately equal to 10 Newton. Another important term which we will refer in the book is rigid body and non-rigid body. What do we mean by rigid body? Now, there are few objects, when you apply force on them, there is no change in the shape and size of the object happen. All the particles or the portions of this object remain intact. They don't move with different speed or in different direction. For example, I have a stone, a heavy stone is there, and force is applied on it. On applying the force, do you think the particles of the stone will move with different speed and in different direction? No movement or no change in the shape of this stone will occur. So, such bodies are called as rigid bodies. Let us underline the definition of rigid body on page number 39 in Do You Know box. A body in which the interspacing between its constituent particles do not change when a force is applied on it is called rigid body. If it changes, it will be called non-rigid body. So sometimes we apply force on object and the object shape, size or no movement will occur in it. Such bodies will called as rigid body. But for instance, if I have taken object like cotton, a very small cotton which is very fluffy, okay, you are applying force on it, you will find that some particles will move in different direction, or some particles are they shifted to certain direction. Or you have a balloon which is half filled with water, okay, so half air and half water is there in the balloon, and when you apply force on it, you will find that particles are showing movement in different direction. They are not intact, they are not moving all together in one direction. Such bodies are called as non-rigid body. Let us underline the next point for non-rigid body. Here we have seen that do not change. Just remove the word not and you will get the definition for non-rigid body. A force when applied on a rigid body can cause only change in motion of the body, but a force when applied on a non-rigid body can cause both change in its size or shape and motion in the body. Okay. Now, next important term is turning effect of force. Till now we have learned these effects, change in the speed, shape, size, direction. Now there is one more called turning effect. When we say turn, means we have rotated the object. Now here I have a ball, or you can consider a pencil, and you are applying force on it. When you are applying force on the ball, what happened? The object is turning in the straight direction. Yes, this object is not stick. This is not placed or fixed to one point, but on applying the force, this object is moving in one direction. But what happens if I take this disc and attach it to the rope? Here this is the rope which is going from the center of the disc, and I have applied the force. Now force is applied in this direction. Object is not moving in the straight path like in the previous case. Here it is turning. It is rotating about an axis. The axis which is passing through its center, it is axis of rotation. What do we call this? Axis of rotation, which passing through the center in this case, and the object is moving around this axis on applying the force. So this applied force has produced turning effect. Turning effect produced in the body when the body is fixed around a point. Now come to the page number 40. Here you can see the example of the door. Now door is fixed to this point, hinge, which we called. Now when you apply the force on this handle, the door is moved about this point. So this force applied by you is called as turning effect of force. Force has turned the door about this fixed point. Now on the page 40, the first paragraph will be the definition for the turning effect of force. Now let us underline this definition. A force has a turning effect on a body which is not free to move in a straight line, but it is pivoted or it is fixed at a point about which it can turn. So this will be the definition for this. Now on what factors the turning effect depends? On what factor? The first factor, underline this, the magnitude of the force applied. How much force you have applied. If you will apply more force on this disc, the disc will move faster. More turning effect will be produced. If you apply less force, the disc will move slowly. And you will say the turning effect of the force is less. Now the next factor is, underline this, the perpendicular distance of the force from the pivoted point. Now what is the perpendicular distance? Look here. Here we have applied the force at the handle, and here is the pivoted point, the fixed point. Now this is called the perpendicular distance from the pivoted point. Now how it is related? Let us underline this. Larger the perpendicular distance of the point at which the force is applied from the pivoted point, more is the turning effect on the body. So more is this distance, more will be the turning effect. Smaller the distance, small will be the turning effect. So till this point, learn all the important points we have covered in today's lecture. Go through all the points again, learn them, and we will be doing some questions based on it in the next session.